It is 13:30, and I think we all had plenty of time to enjoy lunch and maybe even some walk outdoors as we had here in Malmö. I will anyway still wait another couple of seconds in order to let people come on. But I can already introduce Marwa, who's joining me here in the room today, and who comes from Malmö University. And Marwa is today going to present about, or she called her topic, "Circularity is the New Gravity," and I'm quite curious about what is there to come. Marwa is an architect and an associate professor at Malmö University in Sweden. She's specializing in climate-neutral architecture, as well as passive buildings, looking into sustainable ways to build with new and old materials, practice and technology. I hope that describes you well.
That's wonderful.
And you already started sharing the screen, and I think you're welcome to start your presentation.
Thank you so much, Jonas. And hello, everyone, and good afternoon. Glad to be here today. And this very short talk, I will be sharing with you some insights on three main issues, I would say. But of course, with my interest and obsession with vernacular architecture, I have to start all the time with vernacular connections to our contemporary and even our future aspirations towards circularity and low impact and climate responsive architecture or design, if we could also say it like this. I will hint a little bit on dark circularity and how nowadays it is a little bit challenging somehow when it comes to applying some of these circular concepts in architectural design and building construction. And then I will give a little bit of hope at the end. I will not leave you with this gloomy experience with circularity, but we'll shed a little bit of light towards what can be the future prospects and how we can overcome these kind of challenges in order to continue working with circular concepts. So let us start with the vernacular architecture, and it's kind of a timeless way of proving we can design in a sensitive, climate sensitive and low impact design using natural building materials from the surrounding environment. Try to maximize the benefit of using what is available in the local climate from natural resources. Basically, in old times, people used to build with what exactly is there under their feet, as Hassan Fathi, the famous Egyptian architect, used to say. They used a lot of bio-based material from agricultural waste, from farm lands, in order to construct their buildings that along centuries proved to be economically also friendly and affordable to build, cope with the local climate, either it's harsh, hot climate or even harsh cold, if we talk about the Nordic context, for example. The buildings were always designed to be able to be reconstructed again, even after demolition, or if it's the time for end of life of the building, or it is just deteriorating naturally. It is possible to reuse the material again. For example, in this picture, it's just an earthen building constructed out of mud brick, adobe bricks. If we demolish it today, tomorrow we can reconstruct it again from the construction waste. You use a little bit of water again to just remix the construction rubble, and then you will be able to cast again mud bricks. So they gave us wonderful examples in old times on how we can recycle, upcycle, reuse all of our building components. And actually, the communities there were self-sustained, self-sufficient. They use what is available around them to carry on their daily living habits. All the building material, as we said, are resourced and brought from the local environment. As you can see here, it's somehow labor intensive, and that can be one of our challenges that I will talk about later. If you depend mainly on man hours, especially in the European context, I would say it's even more challenging in the Swedish context when man hour is extremely expensive. But here we can see at least the way that in old times, they used to construct their buildings, it's possible to reassemble and rebuild again. All the building layers is possible to, like when it's demolished, it's really possible to bring it back again to life as a new construction with the same basic raw material. So it's almost zero waste construction technology. When a building again is about to be demolished, every single component can be upcycled in different ways. This is a very simple example. This is a door threshold. So if it is possible to reuse it again for the same purpose. If not, it can be just upcycled in a different way, like using it to design a door, a wooden door, and so on and so forth from those examples. A palm nut tree, for example, is not just a source for food, for palm dates. It is a construction material. It can be used for primary beams, secondary beams for roof construction. It can be used for doors, for windows, for also like supporting beams for walls or corners. It can be for furniture, and even the leftovers from the cutting of and trimming of the palm tree shell itself, the trunk, it can be weaved and used as like for different household elements. So definitely it's an example for like definitely zero waste way of thinking. From one material again, this is just earth. You can construct a house, you can construct storage or build storage containers for crops to keep it fresh for a long time in different seasons. You can use it for also interior furniture, for shelves, for cupboards, for built-in sofas and built-in beds. You can even do an oven or a cooker or different kind of utilities that you can use. A waste is not a waste. Organic waste in old times can be used not only as fertilizers for agriculture like purposes. It can also be a way of using it as a fuel. So this is just an organic waste or animal manure that can be used as dung cakes as a fuel for furnaces. When we also talk nowadays about like renewable energies and how we should use different natural powers to generate energy like electricity for our buildings, also in old times it shows us this kind of circular way of keeping on using natural powers, and this was the very initial thoughts for windmills, wind turbines. But nowadays, we think a lot about design for reconstruction, design for rebuilding, and also for design for disassembly. But if we look at the enormous amount of construction waste that is already there, because all the time we think of new, but how about the old, and how about the existing buildings, and how we can reuse all this kind of construction rubbles. Sometimes it's really hard to recycle. It is also a lot of energy consumed, a lot of embodied energy and a lot of embodied carbon still in reusing this kind of construction rubble or construction waste. Sorting construction waste is also time consuming and definitely also energy abusive. However, it's better than producing new material. So it's a little bit less bad, as we used to say, but we still need to do more good, as the slogan says here, since we started this event as a main kind of objective for restoring gender. So some ugly facts, unfortunately, in the EU alone, the construction sector consumes 1.6 billion tons of materials annually, especially like steel and plastics, aluminium, and the biggest consumption is for cement. Of course, there are a lot of initiatives for producing this eco cement or like environmentally friendly cement, but still, if we try to minimize the use as much as possible, that's even better. So some of the challenges that we still face, as as I just mentioned, like it's hard to build new all the time. We don't have this luxury of building new. The process itself of assessment for and reclaiming old material can be also time consuming. We still have lack of standardization as the way like to assess reclaiming material can also differ from one architecture firm to another, from one contractor to another, and that also differs from one country to another. There's another challenge when it comes to building codes and building regulations and building standards. It's sometimes very rigid and it's really hard. I will share a little bit now quickly with a recent project when I tried to build with straw and clay and reeds in Sweden. Also quantifying some of the design like for reconstruction and deconstruction are still sometimes like a very indefinite sense. There is not too many well-recognized conventional methods for doing this. I mentioned also quickly the labor cost. It can be really costly if we depend on this kind of design for disassembly to reassemble our buildings manually. That little hope at the end of the dark tunnel. With this, there's small and humble contribution in designing. At that time, I call it 6 Z's target, which is 0 carbon, 0 energy, 0 indoor air pollutants, 0 cost if you do it yourself, 0 impact on the environment after end of life, and 0 waste like as an outcome from this building. So the idea is to use locally resourced material around the building site, earth, straw, reeds, and wood, to construct a refugee house based on the idea of design for disassembly. So all the material are resourced from the nearby farmlands from the project site. A lot of lab testing has been done to be able to make sure like these materials are safe and good to use, because we cannot, at that time I couldn't find any standards in Sweden that say, okay, I can build with straw and reeds and that is safe to construct, and how it comply with the energy efficiency standards. All the passive systems in the house, the house is mainly depending on passive means for heating, cooling, natural ventilation, and for daylight. A lot of passive systems were used, like trompe walls, screen walls, air heat exchangers. All the waste from the house is recycled. Like the organic waste are used as biofuel. All the water are separated, like gray water and black water, to be reused again in different purposes. Even if there is excess wastewater, it is treated and it goes to the sewage system clean, even better than it's just like dumped in the sewage system. In Sweden, we still have 20% in the waste system. So even if there is leakage, it's still kind of clean water to be used. And here's the construction process. It was like manually done, only with the screwdrivers, step by step, like Lego pieces, to show like it's possible to design for this assembly. So you can unscrew all the building components. It comes back as a straw panels. You can use them again for the same purpose as also construction elements, or you can just recycle the straw as material for animal bedding, or for food, or just a compost or biofuel. And the plywood, of course, it's easy to recycle as well. So that was not our crane, that was the nearest project crane. Everything here is just manual. It took, for this 40 square meter house, 1.5 working days. And the house was done mainly by amateurs. You would just have training during the construction process. So just to prove that it's possible to do it yourself and construct the house step by step in an easy design for disassembly manner. I think I have only 1 minute left. 2, okay. So this is just quickly to show you like the building process. Something happened. So yeah, all the building components are like installed as piece by piece, even the passive systems, the trompe walls, the green walls, and even the renewable energy systems. To summarize, in short, a successful circular design process needs first a client or an investor who is daring and ambitious, but also supportive to the whole circular design process, and a skilled architect, of course, that is who is equipped to do this kind of mission with extensive knowledge and experience on first the available material that he or she could use, and also to find a contractor who is willing to invest in collaborating and building this kind of circular buildings. It's somehow costly from the beginning, but the reward is even better. To end, I would like to say like circularity needs a strong desire and will for change, and active actors in the building sector needs really to step in now and not later, because otherwise it will be too late. Thank you so much for listening.
Thank you so much, Marwa.